Okay, question 6 is about energy transfers, and we've got some apparatus. A metal ball is attached to a thread. There's the thread and there's a metal ball. This is going to act like a pendulum, swinging this way and this way, but it looks like it's only going to swing through the light beam. It says the ball is released from a starting position and then it cuts a light beam at the bottom of its swing. Okay. When the ball cuts the light beam, the speed of the ball is recorded by a data logger. So they must have plugged into the data logger the distance across the ball. Then we've got these speeds here, and it says calculate the mean speed. So we've got to add these three numbers together. Remember to press equals on your calculator and then divide by 3. When we do that, we get 1.247. But remember, we always express our final answer to the same number of decimal places as our results. We can't make the results more precise with a bit of maths. So that's that there. So mean speed equals 1.25. Suggest one reason why the measurements of speeds were repeated. So it's to identify any anomalous results or to just make our results more reliable. Identify any anomalous results and or to improve reliability. Okay, the next one, you can see the question is going to ask you to work out the GPE. So I've just got to multiply whatever they tell me. Let's go and check the units to see if that's correct. So mass of the ball in kilograms, perfect. The height 5 centimeters, not perfect. So divide that by 100 because there's 100 centimeters in a meter equals 0.05 meters. And we're going to need that. And it gives us the gravitational field strength of 10, perfect. And then we're ready. So you can just see the only problem there is you have to change that height. So multiply all that together and you get 0.026 joules. The next one, figure 15 shows an end-on view of the ball's swing. To measure the change in vertical height, draw a ruler placed in position to measure the change in height. So I've just got to make sure I've got a ruler that covers from here to here. So as long as, and let's just place a ruler straight by the side. So there we go, and that will make sure. I would argue that you could do with a little pointer to measure it a bit more precisely. But there we go, that's a nice easy one. Figure 16 shows a set square. Describe how the measurement of the vertical change could be improved using the set square. So if I go back to this, if I didn't have a set square, it could be that this is slightly tilted and therefore my readings won't be as good. But having a set square by the side of it like that will ensure that this is properly vertical. So now we just got to put that into words. The set square label is to make sure the ruler is vertical. So the set square ensures a 90-degree angle, and this will help us make sure that the ruler is square to ensure we get the full vertical height.